what's going to happen now is we're going to transition from the speech of self-introduction, where your goal was to present yourself using a particular slice of what you might call like your personality, some kind of aspect of you that shows sort of the general picture about how you are, but not the whole general picture. So all we're doing now is we're going to switch gears, and we're going to do an informative speech that is essentially the same exact thing. The only difference is that instead of you being the topic, something else is the topic. But you still have to take the big cheese wheel of a topic and get your little wedge of cheese to do in your little 4-minute speech. Now obviously there will be specific skill sets that we'll need to also work on, but ultimately the first thing you have to know is what your topic is, but the next thing you need to know is what your theme is. That's the most important thing. Mostly what I'm looking for today is where the speech works, right? So where you want to give the speech a generous read, where you think that she accomplished her goals, or maybe you can kind of see something happening there, and what failed for you. And so we'll get in groups like we normally do. We'll chat. I'll assign a couple questions, and then I'll have everybody share, and then I can kind of debrief at the end for why this matters for how you're going to do your own speech. So when we're done here, watching the video, y'all can group up, and then I have the outline or the transcript of the speech on ELC, and I've also tweeted it. So if you follow my Twitter, then you can see the link to that right there.
To prepare for the discussion of this video, I first used the TED-Ed custom lesson plan, which I now share on my TED-Ed site, to create a list of questions from which I created this worksheet you're now looking at that would guide student small group discussion after watching the video. In addition, I tweeted and posted to our online learning community the interactive transcript of Pike's talk so that students would have it to watch while discussing and while following along with the video in class. I made sure the video was closed captioned so that students who might be hard of hearing or hard of sight would have an easier time understanding Pike's talk. The video that the students watched in class will now actually play in its entirety. So if you wish to skip the video, move ahead in the presentation about 4 minutes until the teaching in the class resumes.
I'd like to talk to you today about the scale of the scientific effort that goes into making the headlines you see in the paper. Headlines that look like this when they have to do with climate change, and headlines that look like this when they have to do with air quality or smog. They're both two branches of the same field of atmospheric science. Recently, the headlines looked like this when the Intergovernmental Panel on Climate Change, or IPCC, put out their report on the state of understanding of the atmospheric system. That report was written by 620 scientists from 40 countries. They wrote almost 1,000 pages on the topic. And all of those pages were reviewed by another 400+ scientists and reviewers from 113 countries. It's a big community. It's such a big community, in fact, that our annual gathering is the largest scientific meeting in the world. Over 15,000 scientists go to San Francisco every year for that. And every one of those scientists is in a research group, and every research group studies a wide variety of topics. For us at Cambridge, it's as varied as the El Niño oscillation, which affects weather and climate, to the assimilation of satellite data, to emissions from crops that produce biofuels, which is what I happen to study. And in each one of these research areas, of which there are even more, there are PhD students like me, and we study incredibly narrow topics, things as narrow as a few processes or a few molecules. And one of the molecules I study is called isoprene, which is here. It's a small organic molecule, probably never heard of it. The weight of a paperclip is approximately equal to 900 zeta-illion, 10 to the 21st, molecules of isoprene. But despite its very small weight, enough of it is emitted into the atmosphere every year to equal the weight of all the people on the planet. It's a huge amount of stuff. It's equal to the weight of methane, and because it's so much stuff, it's really important for the atmospheric system. Because it's important for the atmospheric system, we go to all lengths to study this thing. We blow it up and look at the pieces. This is the U4 smog chamber in Spain. Atmospheric explosions, or full combustion, takes about 15,000 times longer than what happens in your car. But still, we look at the pieces. We run enormous models on supercomputers. This is what I happen to do. Our models have hundreds of thousands of grid boxes calculating hundreds of variables each on minute timescales. And it takes weeks to perform our integrations, and we perform dozens of integrations in order to understand what's happening. We also fly all over the world looking for this thing. I recently joined a field campaign in Malaysia. There are others. We found a global atmospheric watchtower there in the middle of the rainforest and hung hundreds of thousands of dollars worth of scientific equipment off this tower to look for isoprene and, of course, other things while we were there. This is the tower in the middle of the rainforest from above, and this is the tower from below. And on part of that field campaign, we even brought an aircraft with us. And this plane, the model BA-146, which is run by FAM, normally flies 120 to 130 people. So maybe you took a similar aircraft to get here today. But we didn't just fly it. We were flying it 100 meters above the top of the canopy to measure this molecule. Incredibly dangerous stuff. We have to fly in a special incline in order to make the measurements. We hire military and test pilots to do the maneuvering. We have to get special flight clearance. And as you come around the banks in these valleys, the forces can get up to 2 Gs. And the scientists have to be completely harnessed in order to make measurements while they're on board. So as you can imagine, the inside of this aircraft doesn't look like any plane you would take on vacation. It's a flying laboratory that we took to make measurements in the region of this molecule. We do all of this to understand the chemistry of one molecule. And when one student like me has some sort of inclination or understanding about that molecule, they write one scientific paper on the subject. And out of that field campaign, we'll probably get a few dozen papers on a few dozen processes or molecules. And as a body of knowledge builds up, it will form one subsection or one sub-subsection of an assessment like the IPCC, although we have others. And each one of the 11 chapters of the IPCC has 6 to 10 subsections, so you can imagine the scale of the effort. In each one of those assessments that we write, we always tag on a summary, and the summary is written for a non-scientific audience, and we hand that summary to journalists and policymakers in order to make headlines like these. Thank you very much.
All right, so before we actually start the class discussion, just to give you a sense of how much higher we're aiming in this class than what I would call average sort of college critical thinking, let's look at the customized plan that TED created for me when I asked them to create a customized lesson plan for class around this particular speech. And I think I said I wanted something that did critical thinking and communication. They didn't have a public speaking aspect. So here are some of the exciting questions that they've put together for you. How many scientists were involved in creating the IPCC's 2007 report on climate change? Or F, who cares?
Yeah.
Right. All right, let's go. I'm going to exclude that from my customized lesson plan. I'm doing it with my left hand. Summarize the nature and scale of collaboration in climate science as Pike describes it. Does this surprise you? Do you think it comports with the general public's perception of scientific study? Why or why not? What are your thoughts on this question? First of all, it's 3 questions, so you can pick one of the 3. But what do you think? Is this a conversation you want to have?
No, why does any of it matter?
That's a good question, does it? I could make the argument that some of this matters. That in fact, unbeknownst to TED, they have given you a good question in this bunch.
Is it sort of like a silo effect where everyone kind of does a minute part, but they're not always aware of the whole?
Right. So when they say summarize the nature and scale of collaboration in the climate science, does anybody want to say why TED is doing you a disservice as the audience member to ask you to validate her methodology?
Because then you don't get to form your own opinions. You just have to say, like, this is what she said. You don't really have to think about it.
Right. Because they take for granted that what she did was good.
Yeah.
It's not a good, the way she describes the nature and scale of collaboration makes it seem like this is what she should have done. Because then you have to summarize it, right? It's not about critiquing the nature and the scale. It's not a good way to describe science, atmospheric science. So number 2, does it surprise you? Are you surprised by how much work went into this process? No, because you're in college. You understand science is hard. Most of you get that, right? Science is hard? Okay, good. All right, moving on. Do you think it comports with the general public's perception of scientific study? Now, this question, I think, holds some intrigue. Why or why not? So what we're going to do is we're going to stop now, and you're going to discuss this question. Do you think it comports with the general public's perception of scientific study? Because I think this question actually has some potential. So we're going to focus on this. So take about 5 minutes in your groups. I'm going to pop the lights on, and then talk about whether what Rachel Pike talked about matches how you think the general public believes scientific study to operate. Okay? And if you want the transcript, again, Twitter, or it's on ELC under the in-class discussion assignments. Okay? And I'll walk around and talk to see if you have any questions or you want to run anything by me. We want to talk about whether or not what Pike said comports with the general perception of science and climate change and the efforts behind climate change. Go. Yes, no, all answers are right. Kinda, sorta.
We said that it's hard for us to really get an accurate description of what the general public, because we're in such a bubble, that like, of course we're gonna think that, yeah, of course this is how science works. It's all this research and all this data that goes into writing this one paper on this very small aspect. But like, maybe most people don't know that.
Okay, so sounds like we've got two answers. So if you're the this is a great question, am I the general public? I think that's an important thing for you to always keep in mind. Also, is there such thing as the general public? But let's suppose you're the general public. So the people in this room, if you're the general public, does this comport with how you understand science to work? Okay, which is how? How do you understand science to work?
It's complex and requires a lot of studies, like repetitive studies about small topics.
Lots of trials, lots of experiments.
It's very thorough. Involves enormous effort on the part of multiple people for one paper to be published.
All right, so these are all facts. In terms of how you perceive the effort, like when she describes her job to you, if I was to say that we gave her a $2.5 million grant, would you think that seems like a wise investment? And let's say that's the size of an average grant. So yes, it does require complex studies, repetition, specialization. Are you pro or con? Are you giving her $2.5 million?
Based upon what she told us, she really didn't describe what she was actually doing.
Yeah.
Or what the
What's her
molecule
research
affected
doing?
us. So we didn't understand.
Right, so those are two different answers. So notice you said she didn't describe what her research is, what she's doing in her
Like
research.
the biological relevance to us.
Right. So that's what I mean. She absolutely described what she's doing.
The methods, basically.
She didn't describe, right, why. What's the payoff?
Like, why do we
So, in that sense, you've got a speech that is highly complicated, specific, hard to understand, detailed, and also feels kind of irrelevant. Do you think if you went to anybody, you, your neighbor, the general public, your parents, average person on the street, and said, hey, did you know that science is highly specialized, very expensive, and largely we don't know what it's for? They would go, yeah, that's about how I feel about science. Yeah. So that's sort of, I think, the interesting thing about the speech is it does comport with how I think the average public feels about science, because they think it's probably a good thing, but who the hell knows how it works, and it probably sounds real expensive and like I'm not going to be able to understand it. But it also doesn't comport with the understanding of the average public, because the average public would feel from the start that they could not listen to this speech because of the degree of specialization it appears to require from the person listening. Okay, so in that sense, I think this was a great question for TEDx to put in a lesson plan, because I think this is an important thing for you to think about is the speech doing, challenging, however, and I think both answers are, it's not a very good speech because number one, it reaffirms everything about science that people are suspicious of. Overly complex, hard to understand, who knows what this is doing, right? And then also, it's for a very specialized audience in a lot of ways because she's talking about very minute procedures. So she's missing what we call like the big picture. All right, so now, what's up?
Was this speech intended to be for a general public audience?
To the degree that all TED Talks are about that, yeah.
Okay.
I mean, there's more and less degree of specialization, but in general, the goal of the TED Talk is to take a specific, isolated sort of concept within academics and business, right, whatever, how Steve Jobs invented the iPhone, and make it sort of part of popular intellectual culture, right? From there, thinking about the assignment you've got coming up, let's talk about Rachel's speech. So you've got the outline. Maybe take a couple minutes in your groups to talk about it. So we know what's wrong with it, right? It's overly specialized. It reaffirms all of the bad stereotypes about science, and we don't really know the point of the study. So fix it for her. Somewhere in this speech is her number 2 word. Her middle signifier is in this speech. She says it twice. She has an argument and a very clear point to be made that she has not yet made. So you be Rachel's translator for me, and you let me know what you think the answer is. So just like the baseball speech, rewrite the central idea and pick the evidence from the speech that you think is already there that is terrific. You don't need to add anything. She's got all the raw materials. Also, think about the number of words per minute that she is speaking in this speech. See if you can guess. Yeah, okay, we'll talk about that in a second.
She like talks much.
Okay, let's go ahead and bring it back up. And to kick off our discussion, I want to, first of all, I want to learn how to use technology. So, desktop computer. So notice that this is another question from the custom lesson plan. And this custom lesson plan says, what's remarkable about isoprene? Why might it be particularly important to understand more about this molecule in the future? In your discussion of how you would improve Rachel Pike's speech, did any of you talk about evaluating and redeveloping her study of isoprene? Okay. So what did you say about isoprene? In relationship to her speech. So why is isoprene the key to the speech? Why is this a very important question for us to consider?
There's a lot of it.
I think it's the key to her audience connection that's missing. She talks about the fact that there's a lot of it, like you mentioned, but she misses like what its significant is. You know, like there's a lot of oxygen in the air. That's not a problem. You know, like why is this relevant? Are there ramifications of it being there that we need to know about? That kind of thing.
So your advice to Rachel is to rewrite the speech about the relevance of isoprene to the audience. Does everyone agree? No? Okay.
It's definitely like.
I hate how this thing makes my little hands look.
You have to like give a reason.
It's like the
All right.
context, you know? Like she's missing the context for it. It's definitely more of like a 3 or a 4 rather than.
Okay. All right. I love that. That's awesome. Way to use your language. So isoprene right now is like a 3 or a 4. Good. And I think that's actually where it stays. I think it's a good 3 or 4. So what's the 2?
Effort. Is that her number
Ooh,
2?
effort's pretty good. So you think the theme might be effort? That's a pretty good start. All right, Emily says effort. What else we got?
Understanding. Like, scale.
We got scale.
All right, well, let's stick with Sam for a second. Give me an example of where you see understanding. I don't think you're wrong. I don't know that I see that emerging. It's more of a number 1 for me.
Okay.
Do you kind of agree with that?
Yeah.
Right. So for her number 1, she's definitely got understanding. Right, community effort, the goal to understand. So community would be another sort of number 1 for me. Again, what's a number 1 term? What's the distinction between a number 1 term and a number 2 term? Right. Number 1 are sort of empty big terms that we all can agree on. Understanding is important in science. Community effort in science. Collaborative knowledge, that kind of stuff. Those are all big ideas that we can all sort of like, get on board with. Then we get into smaller things. So then that's where Emily, I wonder if effort actually might be kind of creeping over into number 1 for me. All right. So then let's keep moving down for number 2. Now let's go to Andrew, and you said scale. I like it. Why do you think it's scale?
Pretty much the entire first half of her speech was talking about the scale of the effort and telling how many people were working on what.
Good. So this is really interesting. So she uses scale twice in the whole speech. Oh, I gotta find the transcripts. Where does anybody know where she uses it?
It's
The
at
first
the very
and the
first
last.
sentence.
It's the very first sentence, and it's the very last sentence. That's really, really weird. Why is that weird? Based on what we know about how to outline a speech.
Because we don't pick up on it because usually the first sentence you say isn't the most important thing.
Right.
Yeah.
She has put the most important argument of her entire speech in the very first sentence of the introduction, which means you miss it, right? So let's view the transcript. Okay, so the transcript says, I'd like to talk to you today about the scale of the scientific effort that goes into making the headlines you see in the paper. Headlines that look like this, video, when they have to do with climate change, and headlines that look like this, video, when they have to do with air quality or smog, They are both two branches of the same field of atmospheric science. Right, so she says she's going to talk to you about the scale. And then what does she do in the second paragraph?
She throws out a lot of numbers.
She talks to you about the scale, right? What does she mean by scale here? When she says I'm going to talk to you about the scale, what does she mean? 15,000 scientists, 620 scientists, 1,000 pages, 40 countries, 103rd countries, big community, huge, so big it's the biggest scientific meeting in the world. So what does scale mean for her in that moment?
People? How many?
Like scientific effort.
Oh, sorry, you're actually getting too smart for me. It just means giant. So when she says scale there, she means giant, right? So she's just trying to establish how giant this is. Giant, 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 giant. Then what does she do starting at 111?
She's talking about how small it is.
Right, so now scale means what to her? Tiny, tiny, narrow, narrow, narrow. And this is where isoprene suddenly shows up, right? Because isoprene represents the tiny scale of the very, very giant effort. Good, okay, so now let's just talk. So let's suppose her whole job, right, is, hey, I just want to let you know the scale of the effort that goes into this science. Let's suppose that that's her point. She just wants you to understand how big it is. Or how specialized it is, or whatever scale is kind of meaning for her. If that's her goal, what do you keep and what do you dump from the isoprene conversation? What are we keeping? What are we dumping? You're her coach. You're now a TEDx coach.
I like the comparison with the paperclip because that kind of puts it in perspective of what the molecule is. But she needs a relation to the audience that the audience is like, oh, isoprene is good or isoprene is bad. All she says is that it's important and it's a lot.
All right, Emily, you are an interesting, educated woman. And I'm talking to you about a very complicated molecule called isoprene. And it is one of the keys to the way that the atmosphere works because it incorporates some kind of balance of oxygen. As you can tell, I don't really understand what's going on. All of that, and my audience connection to you is to say, it's just like in your house when you have 3 paper clips. That's the same weight as isoprene.
I was
Now
thinking,
tell me
like,
how you
size.
feel.
Yeah, no.
Right. It's insulting. It's good, right? If you're going to give her the generous read is that was nice. She did stop. She put the paper clips up there. She tried to make a connection with me. But it's an insulting connection. It's sort of like when you stand up and you're like, as human beings, we've all been birthed. All of us have been produced into the world, you know, and then now I'm going to talk about something totally specialized because, hey, I've connected, I can move on now. So she's insulted you at the same time she's trying to talk to you intelligently about this molecule. So I think if I could rephrase you, is it fair to say it's a swing and a miss on that one?
Mm-hmm.
So you like the idea, but it's too, yeah. So would you keep the paperclip or dump the paperclip?
I don't like the way she went with it, but a paperclip is a very known. So like I think she needs to choose
what
another.
awesome public speaking strategy do you have in your back pocket for her to relate the isoprene to the audience that doesn't require her putting up a paperclip? What do you know that she could do instead? If she needs you to understand something that is not known.
So she would use an analogy.
Right. Now the question is, what tenor? What's the tenor you would use to transfer from isoprene or from this other thing over to isoprene? So I'll let you think on that. What's up, Jeff?
I just don't think that weight is like a very good.
I agree.
Yeah.
Right.
It's like,
And I think that's kind of, what Emily was saying. It's like, well, the tenor wouldn't be, it's light. Who the hell
I
cares?
mean, every molecule is going to be like that in relation to like a
Good. All right, so I think generally we're understanding isoprene maybe has a role, but so far we don't know what that is. Okay, so now let's talk about the rest of it, because I think we're kind of iffy on isoprene. How about this trip to Malaysia? It takes up a pretty solid chunk of the speech.
I like the part about the airplane, like when she started talking about like the flying. I'm like, oh, that's cool.
Why is it cool?
Just because it's interesting. That
Why is it interesting?
Because
Use your number 2 words.
It's interesting because it shows a part of science that kind of, it's not just boring doing formulas. You're active. You're doing something that might be considered dangerous.
Right,
challenges
dangerous.
the
That's
stereotype.
kind of where I was going. Find a sentence where she makes the plane trip the coolest. We also fly all over the world looking for this thing. I recently joined a field campaign in Malaysia, yada yada. Global atmospheric watchtower, middle of the rainforest, hundreds of thousands of dollars of equipment, blah, blah, blah. And then she says, tower in the middle of the rainforest, and here's the tower, and tower, and tower, and here's the tower for you. What do you got, Jeff?
For me, like, the coolest part is when she talks about having a higher military.
Yes!
violence.
I agree. I don't care about the rest of the stuff. It's when she's like, this is so crazy that we have to get military and test pilots to like loop around in a giant circle because it's so dangerous that this is what we do. Good. So, do you care that it's a BA-146 that's run by FAAM, normally flies 120 to 130 people?
No.
Do you care, or rather maybe care is not the right adverb there, but maybe you took a similar aircraft to get here today.
I rolled my eyes at that, honestly.
Good. It is just like what other part that we just talked about in the speech. It's the paperclip. Oh, you're so smart, right? It's the paperclip. And this is a thing that we do, right? We don't know how to connect with the audience through the theme, which is what matters. So instead we throw in these crappy like paperclips. Hey, you fly planes, right? Noah just looked at me and went. All right. So, but then you're like, look, this plane trip is so crazy dangerous that we have to get test pilots. And there's a kind of subtlety and simplicity to that that just makes you go, whoa. You don't really need all the photos and stuff. And then you could throw in a joke like, so you've been in planes. I bet your plane don't look like this plane. And that's funny. You know what I mean? That's cute. You can do that. But it's not, I mean, it's not a substantial audience connection. It's just a little stylistic flourish. Why does it matter that the plane flight is dangerous? What you got for me, Adam?
That kind of like, I guess, implicitly proves the importance of what they're doing. Like, if they're going to go to all those lengths to try to get this information, but then she doesn't really tell us like why it's important.
Okay, let's keep running with that. I like that. Ruthie.
I was just going to say it's kind of a reflection of the scale because she was talking about the molecule and how it's so small and like you're risking a bunch of lives to like capture this molecule, study it.
Now we're getting exciting.
And
we're risking
then,
lives.
like make one headline.
There! That's it. Now say that as a sentence.
What is a sentence?
The thing you just said, but say it as one central idea, and we have it. We have solved the mystery of the speech.
So risking lives to make a headline?
Right.
Thank you.
We risk all of these lives, and then out of it, we get one headline. Which is to say what?
Headlines are more important than lives.
According to whom?
Scientific community.
No, according to the
According to general-
journalists. We do all this work. Hundreds and thousands of pages of writing. Lives risked to fly through the air with crazy military pilots to capture maybe one molecule. Hundreds of millions of dollars of scientific equipment invested. We're the largest scientific gathering in the whole entire world. We have every paper that we write is reviewed by upwards of 1,200 scientists, right? 620 plus 400, to get one headline that looks like this. Oh, hold on, I lost my dramatic pause. Where's my image? There we go, that looks like this. What does she want to say to you that she cannot say or slash is not saying? Let's go back to the beginning. I'd like to talk to you today about the scale of the scientific effort that goes into making the headlines you see in the paper. What do you got, Ruthie?
She wants to say like these journalists are trivializing us and you don't even know.
Trivialization. That's the word. That's it. Trivialization. Scale, trivialization. They're related, right? Because the scale of the effort is so disproportionate. And she means scale in the big sense, the quantity of people that are working on this, and scale in the micro sense, the tiny specificity with which we work. And all that so you get one headline. And notice, of course, the headlines she chooses, too, are what kinds of headlines? The three she chooses to show you.
Big and dramatic.
They're
like,
big and dramatic and alarming, right? This is a big screw off to journalism, is what this is, right? We put all this work into it, and you get one headline. It's a load of crap. It's disproportionate. It's not representative. And I think, in a weird way, she also thinks it's insulting to the American public. But then she insults you. It's a really strange speech, right? She's both insulting the American public by being like, look, you fly in planes, but also she's saying they can handle it, right? They can handle understanding something more complicated than a boiled down headline. And I think the reason that I know I'm right, other than the fact that if I pretend like I'm not right, then I lose all my cred, but it's because of the conclusion of the speech when she says, we do all this, and I can just hear, like, if I were delivering this speech, it would look like, we do all this to get one molecule. And then one student like me, right, student, she's not a scientist, she's a student, has some sort of inclination or understanding about that molecule. So that says what to you, that phrasing? She's like, and then some student like me has one inclination or understanding about the molecule.
She's almost like discrediting herself.
Yeah, it's weird. I don't know that I would have said it this way, but the point she's trying to make is like, look, this science is a crapshoot in the dark, right? We're doing all this work, and then anybody who even like maybe guesses that the molecule might weigh different than we thought or whatever, goes and they publish one paper. And out of a whole campaign, out of all the crazy up-down, whirly-dingies, doohickeys, upside-down, roundabouts, right, we get a couple of papers. And as the body of knowledge builds, it will form one subsection, or one subsection of an assessment. And each one of the 11 chapters has 6 to 10 subsections. And then she says it again. You can imagine the scale of the effort. She's repeating herself. It's got nice symmetry, I will say. Her intro and her conclusion, it's cool how they're saying the same thing. I do respect that about this. In each one of these assessments, we always tag on a summary. She just talked to you for 3 minutes and 50 seconds to get to the summary, right? There's a certain kind of poetic beauty to that. I'm going to spend 3 minutes and 50 seconds on corn and paper clips and zeta alien till the millionths and plane photos in Malaysia and what the name of the plane is. And then at the end, it's like, oh, by the way, there's a summary. I mean, it's almost so brilliant. I wonder if this is maybe the greatest TED Talk in the history of TED Talks, right? And the summary is written for a non-scientific audience, and we hand that summary to journalists and policymakers. And then they make headlines like these. So you got to think about it. It's a process, right? And it takes all these steps. And she spends the whole time on the science part, but she started out and said, I'm going to tell you the science behind the headlines. But you don't see how the science becomes a summary, becomes the journalist, becomes the headline. You just see all the science, and at the very end, it's like, oh, and then there are headlines. I mean, whether or not she meant to or not, this is a screw you to journalism. This is like, you have no idea how much work goes into this. We don't even know if we're right half the time, and you are putting all of this climate change paranoia into the earth with all these summaries, and we don't even know if it's right. You know, so that's the polemic, debatable kind, but the central idea of it is just it's disproportionate, you've trivialized, right? If you wanted to say it sort of less polemically, you would say it is disproportionate the amount of effort we put into this research versus what is circulated into the public. And I think that would be a very reasonable, informative, central idea for a speech that could now eliminate some of the stuff we don't love, keep some of the stuff we do, and be more relatable to the audience, because you guys understand disproportionate, right? You understand the idea of putting too much effort into something and getting crap out of it and being reduced, right? Test grades, I mean, great example. You understand what she's talking about. You don't need paper clips. You get it already. She just hasn't gotten there yet as a thinker. Okay, we had some hands, and then I got to wrap it up because we got to check your participation homework, and then I got to let you out of here on time. So what do you got?
So one thing was when you said the way I wonder if she set that up in a way to all the examples. It kind of mirrors how she talked about the summaries. That's what I keep thinking.
It is. It's so brilliant. I know, and it's hard. By the way, don't do that. Don't be like, I'm going to be the Rachel Bunny of public speaking. Say what you want to say and do it really well. But I think in some ways, she's a smart woman, right? She has an argument to make. She can't stand up and just make it. You can't go on a TED Talk and be like, screw journalism. I mean, they don't run that way.
Yeah, just the way she did it.
Yeah.
You think about the summary of it, the most of the summaries in the paper are this is this, but the science behind it is not mentioned, which is just her how her speech was. The science behind it is not mentioned. Only the stuff that seemed kind of interesting to the public is mentioned.
Yeah, and I think this sort of begs a really interesting question. You kind of know now that we've gone over it, it's very clear what she's doing, right? Now you can totally see it. Why couldn't you see it the first time we watched it, other than the fact she doesn't have an explicit central idea? Why couldn't you pick up on it the first time? Because she talks too fast. If this speech were 600 words and she paused, I bet you'd get it. I bet by the end you would have and I would also add, she needs to add that, I'd like to talk to you about the scale. It would look a lot different if she wrote, Headlines look like this, about this, this, and this. They are both. For example, we had this one headline about climate change. There's 1,000 pages, blah, 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 blah. Today I'd like to talk to you about the scale of the effort that goes into the scientific headlines. If she'd said it that way, you would have picked up on it immediately. And that's kind of how I know I think some of this is just bad writing. Because it is a tried and true principle. You do not ever deliver your central idea in the first sentence because nobody can hear you in the first sentence. They are not with you yet. So, but I do agree, structurally this is beautiful. Content-wise, it has a lot of work. And there was one other question maybe from Will.
I was just gonna say a similar thing, like the idea that that those people who are in science like spend so much time and then like the journalists take it like in 1 second they create a headline. And it's just illustrated through the fact that she spends 3 minutes and 50 seconds on what the scientists do and then 10 seconds on the journalists.
But you can imagine what the speech would be like now if we moved the introduction around a little bit, cleaned up some of that isoprene stuff, but then still had the same rapid bring it to a close with the summary. It'd be beautiful. It would totally sneak the theme in through the back door, give a little like to the journalists, still get to focus on the work that she does, and clean up the details so you get a little more of a sense of how the effort is so not represented in the headlines. So it's not like it's a bad speech, it's just its potential is so underutilized. And that's kind of what I want you to start thinking about with your informative speeches. You've got 4 minutes. Think about if you really need all the stuff you're putting in there and focus on your theme. And then once you know what your theme is, then we can think about structurally how you could make it a little bit cooler, how you could do sort of this heavy loading in the front, light loading in the back to make the audience feel the point of the speech. But first you have to know what it is. And honestly, I don't know that she knows what it is. I think she just is intuitive enough that it worked out this way. I don't know. It'd be really cool one day to try to find her and interview her and see if she knew the whole time what she was doing. My hunch is not, though. My hunch is she sort of was like, no, I just wanted to talk about how we produce the science. And it's kind of like, well, weren't you going to needle the journalists a little bit? And she's probably like, no. That's just how summaries work. You know, I can see that sort of being her perspective.